home without parental supervision?
Ever.
So what I want to do today is I want to smash this can. I want to crush it. Okay? But I don't want to do it the way other people do it. Other people show off their brute strength and they smash it on their head, or they step on it, or they crush it with their bare hands. I'm non-violent. I want to use science to crush this can. I want to do the same thing. I want to make a nice, great implosion, not explosion, an implosion. And I want this can to collapse on itself. But in order to do that, I have to know some things about science.
I'll make the can expert.
Sure, but it's not something I would ever want to do in a class demonstration. There's no explosion that I would feel is safe enough. You can watch Mythbusters all you want to get your explosion. Now, what's in this can?
Air.
Thank you.
Wow, nice job.
I thought someone was going to say nothing. There's air in this can. It is not nothing. Look, I'm cutting it off and I can't, now the air won't escape. Air in this can, okay? So, does anybody know what this thing is?
Nope.
Test tube?
It's not a test tube.
It's a tube.
It is a tube, but that's not the scientific name we have for this. Graduated. This is a graduated cylinder.
He graduated.
Now look at it. Why do we call it graduated? Because it's very smart and it graduated?
Yeah.
Yes.
No,
Yes.
that's not why we call it graduated cylinder.
Because the inches graduate up the tube.
That's fantastic. Now it's not inches, I'm going to go over what it is in a second. But look, it's graduated because the numbers are gradual. They're graduating. Anything like a thermometer, any kind of measuring device that is gradual is called graduated. So we call this a graduated cylinder because the shape is a...
Cylinder.
Now, what does a graduated cylinder measure? The volume of liquid. Now, volume is how much space something takes up. We know that matter is anything that takes up space. Volume is the measurement of that. You use a graduated cylinder and you use the measurement known as ml. What does that stand for? Milliliters. What is it?
Milliliters.
Milliliters. Anyone ever going to take your 15 milliliters of liquid of H2O and you're going to drop it in your can. By the way, what's now in this can?
Water and air.
Water and air. Okay. What we're going to do is we're going to boil what's in our can. Now, how do you know something's boiling? Yes?
It's all bubbly.
It starts bubbling up, the H2O starts bubbling up. So will I hear it boiling?
Yeah.
Okay, so I'll hear it. Will I see it boil?
Yes.
What am I going to see? If I was visualizing, what would I see?
Bubbles coming up.
Yeah, what if I mean, it's through the can. I can't really see the bubbles. What, can I see anything else?
Like
Oh.
water coming from the outside of the can.
What is that called?
Like evaporation.
Evaporation.
Aluminum.
You hear
It's
it?
the can. It's like the steam coming up from the can.
Good. It's the, you hear it?
Yeah.
Is it the aluminum?
It's crying. There's no crying in science. Let's see. Anybody know the temperature that water boils at? Fahrenheit?
300 degrees.
It's an area code in New York City that starts with a 2.
212.
212. Take this can. I'm going to go put it in the very cold water. Okay? And we're going to see if our science abilities were able to crush the can. It's been boiling for a while. We all agree that now what's in this can? Yes, your hands raised.
Air and water.
Air and water, but not just liquid water, but your hands raised.
No.
Water starts with a V.
Oh. And vapor.
Water vapor. Okay? So we have some vapor in here. Now, Is most of this now is water vapor. Now when I instantaneously put it into something really cold, what happens to those water vapors when it gets cold again? It becomes goes back to a liquid. Instantaneously goes back to liquid, pushes the rest of the air out of the can, giving us more air pressure on the outside of the can than on the inside of the can. Oh, even giving us homemade air can.
Awesome.
What's inside this can?
Nothing.
Nothing?
Rhythm.
How's nothing feel?
Rhythm.